Hey there, and welcome. Today, we are going to tackle one of the most useful skills in all of algebra, solving proportions. Now, it might sound pretty basic, but trust me, getting this down is the key that unlocks how we solve much, much more complex equations down the road. So, let's jump right in.
So just think about this for a second. This isn't some random math problem, right? This is a real question you might ask yourself in the kitchen. And guess what? The perfect tool to solve it is a proportion. This is exactly why they're so important. They show up absolutely everywhere.
Okay, so here's our game plan for today. We're going to start with what a proportion actually is. Then I'll show you the powerhouse technique for solving them. We'll walk through a few examples, cover the common mistakes you'll want to avoid, and wrap up with why this all really matters. All right, first things first, let's build our foundation. Before we can solve anything, we need to be totally clear on what a proportion even is. A proportion is just an equation where you set two fractions equal to each other. Yep, that's it. Anytime you see something like A over B equals C over D, you are looking at a proportion. It's the simplest kind of rational equation out there, and it's our gateway to handling the really tough stuff later. Now for the fun part. How do we actually find a missing number in one of these things? Well, we use this beautiful, simple, and super fast technique called the cross-multiply method. And you know what? The name tells you exactly what to do. You just multiply diagonally, kind of making an X across that equal sign. This one simple move instantly changes a tricky-looking fraction problem into a much friendlier equation. And here's what you get. The proportion A over B equals C over D becomes A times D equals B times C. And just like that, poof, the fractions are gone. That's the real magic of this method. It turns a rational equation into a simple polynomial equation, which, hey, we already know how to solve. But, it's really important to understand why this little trick works. It's not magic, it's just a shortcut. The long way to do it would be to multiply both sides of the equation by the common denominator, which is B times D. And as you can see, when you do that, everything cancels out and leaves you with the exact same result. It's a fantastic shortcut, and it's built on solid algebra. All right, theory's great, but you learn math by doing math. So let's put this method to the test. We'll start off with a basic one and then ramp things up a bit to show you just how powerful this technique can be. Here we go. We've got x over 3 equals 8 over 6. So step 1, we cross multiply. 6 times x gives us 6x, and 3 times 8 gives us 24. That leaves us with the simple linear equation, 6x equals 24. Just divide both sides by 6, and voila, x equals 4. See, not so bad, right? Okay, let's level up a little. Now the variable x is hanging out in the denominator. But hey, the process is exactly the same. We cross-multiply, and we get 5 times the quantity x plus 1 equals 3 times the quantity x minus 2. Now this next step is absolutely critical. You gotta distribute. That gives us 5x plus 5 equals 3x minus 6. From there, it's just some basic algebra to get x by itself, and we find out that x equals negative 11 over 2. Whoa, okay, look what happens here. When we cross-multiply, this one, we get x times x, which is x squared. Just by following our simple rule, we've turned what looked like a basic proportion into a full-blown quadratic equation. So we get everything on one side to set it to 0. And since this one doesn't factor nicely, we bring in our old friend, the quadratic formula, to find our two solutions. It's a perfect example of how one concept in math builds right on top of another. So, getting an answer is one thing, but getting the right answer is what really counts. Let's talk about the common traps that people fall into when they're solving these. So there are two really big ones. First, just like we saw in that last example, forgetting to distribute correctly. You have to multiply that number on the outside by every single term inside those parentheses. Second, and this one is huge, is forgetting to check your answer. You have to make sure your solution doesn't make one of the original denominators equal to 0. Seriously, this is non-negotiable. It's the golden rule for any rational equation. Remember, you can't divide by 0. It's mathematically impossible. It's undefined. So any solution you find that would cause that to happen isn't a real solution. You've always got to plug your answer back into the original equation. If a denominator becomes 0, that answer is what we call an extraneous solution. It looks right, but it's a fake, and you have to throw it out. So, we've figured out how to solve them. We know what mistakes to look out for. But why? Why do we spend all this time on proportions? Why does this one skill matter so much?
Well, because proportions are, and I mean this literally, everywhere. Remember that recipe from the start? That's just scaling with a proportion. Converting from miles to kilometers? That's a proportion. Reading the scale on a map? Designing a building? Even calculating the right dose of medicine for a patient? All of these rely on the fundamental idea of two ratios being equal. This isn't just abstract classroom math. It's a tool for understanding and navigating the world around us.
And that really brings us to the big takeaway here. By getting great at this one skill, you haven't just learned how to solve for x in some fractions. Nope. You've built a foundational key that's going to unlock entire new worlds of more complex equations. You've laid the groundwork. So the only real question left is, what are you going to solve next?